Good morning, students, and good morning to all of you. Today we are going to discuss a topic: mass and weight are same. Is there any difference between the mass and weight? Let us see here. What is the mean by mass? Okay, mass is the measurement of inertia. We know that. We can write here mass is the measurement of inertia. Then there is a term inertia. What is inertia? Then we can write here that inertia is nothing but it is a resistance. It is resistance offered by any object so that the object does not want to change their state, so that the object does not wants to change their state. Okay, what is mean? Let us see here. Inertia is nothing but it is a resistance offered by any object, so that the object does not want to change their state. If the object is in motion, then object wants to maintain the state in motion, and if the object is in rest, the object wants to maintain the state in rest. It is a resistance offered by an object, so that it does not want to change the state. Okay, let us see here what is the inertia. Suppose a object having a mass of m1 and another object having a mass of m2, and both object carrying a force, or we can say that the both object having a force, the same force F. Then what is about its acceleration? The acceleration, we can say that acceleration becomes how much? F upon m1, and the acceleration of the object m2 becomes F upon m2. We see here that the denominator of both objects are not same, but the numerator of the both object, or the fraction of the both object having the numerator same, but denominator are different. Then we can conclude from here that the a1 or the acceleration of object m1 is larger. The acceleration of object m1 is larger in compared to the acceleration of object m2. How it is possible? We say from we see the both fraction. Here we know that the m1 is less than m2. We have to consider here that m1 is less than m2. So as the denominator of this fraction increases, the value of a2 will be less, or we can say that the numerator are same, but the denominator is larger in value in compared to the m1. Here m2 is larger than m1, so the whole fraction, that is the a2 becomes less than m1. So we can say that from here the m2 having more resistance power, so that the m2 does not want to change the state more easier than m1. Here the m1 having a low resistance in compared to the m2. We can say that m2 having more inertia in compared to m1. The m2 having more inertia, because the m2 does not want to change the state easy, but m1 having less inertia, it wants to change the state easier than m2. We can see here the a1 having a1 is greater than a2, so we can say that the m1 having less inertia, or we can say the m2 having the more inertia in compared to the m1. Okay, in other words, we can say that the mass is the measurement of The mass is the measurement of actual quantity present in any object. Okay, the mass is the measurement of actual quantity of material, you can say of material, actual quantity of material present in any object, and its SI unit is kg. It is measured in kg. It is fixed for anywhere in the universe. It is fixed for anywhere in the universe. It is a scalar quantity. It does not having any direction, so it is a scalar quantity. It is fixed for anywhere in the universe. Where you put, if you put the mass of an object on the moon, the mass of an object on the moon is same as the mass of an object on that object on the earth. In another hand, let us see here about the weight. Okay, suppose this object is falling down. Okay, suppose an object having a mass m and it is falling down. Then we know that the object having a mass m having some acceleration, let us see here a, then there is a force which is acting on that object. Then what about the force? Mass into acceleration, and we know that here the acceleration is acceleration due to gravity, a value g equal to 9.8 meter per second square, or approx we can say that 10 meter per second square. So here the force which is acting on object m so that it is falling down, this force is nothing but, this force is a weight. We can consider the force is nothing but it is a weight. Here we can say that m into z, a is equal to z, so we can write here the weight is nothing but it is the product of mass of an object and the acceleration due to gravity. Acceleration due to gravity of earth. Okay, I think you are able to follow me. So the weight is nothing but it is a type of force. So its SI unit becomes how much? Its SI unit becomes kg meter per second square, that is Newton. Okay, and it is not fixed for anywhere in the universe. It is differ from place to place, because the g will be differ from place to place. Let us see here about the g. We know that the earth is in the shape of oval, not complete sphere. So we know that, suppose this one r1, okay, suppose this one r1 and this one r2. We know that here the r1 is less than r2. So if we put an object here, the distance between the center of the earth and the center of an object is here less than in compared to the here. So we can say that here the g, suppose this one z2, here the acceleration due to gravity is z2 and here the acceleration due to gravity is z1. So we can say that the g1, that is g1 is greater than g2 because the distance between two objects is less. So we can say that it is differ from place to place, means as the g differ, so weight is also differ, and it is a vector quantity. Okay, it is a vector quantity because it is having a direction. It is a vector quantity. Okay, it is a vector quantity. If you place an object on the moon, then weight of an object on the moon is 1/6 time weight of an object on the earth. It is fact. It is calculated value. Weight of an object on the moon is 1/6 time. Suppose an object having a weight on the earth is 60 Newton, then weight of an object on the moon becomes how much? 1 upon 6 time means weight of an object on the earth divided by 6 becomes 60 upon 6 equal to how much? 10 Newton. 10 Newton means the weight of object on the moon becomes 10 Newton. This is the difference between the mass and weight. Mass and weight are not same things. Mass is the actual quantity of an material present in an object, and it is the measurement of inertia, and inertia is nothing but it is an resistance offered by an object so that the object does not want to change the state. If the object is in motion, then it wants to maintain the state in motion, and the same object, if the object is in rest, it wants to maintain the state in rest. Whereas the weight is nothing but it is a type of force which is acting on any object to pull down. Okay. Again, suppose this object is falling down and reaches to ground. Okay. Suppose this object is falling down and reaches to ground, then what about the weight of object when it reaches the ground? Here, when it is reaches to ground means the object is in rest. Okay. The object is in rest. Here the object is reaches to ground after falling down. It reaches to ground, then it becomes it comes in rest. It comes in rest. Then what about the weight of an object? Is the weight is 0 here? Is the weight is 0 here? No. Here the weight is not 0. You know that when the object is reaches to ground means here acceleration becomes 0. Here we can say that accelerations become 0, but the weight of an object is not 0, because a continuous force is acting on an object, that is weight equal to mg. The g, that is acceleration due to gravity, is not 0. Acceleration is 0 because the object is in rest, but acceleration due to gravity is not 0. And opposite force is acting on an object, that is normal reaction force, when object is in contact between the earth surface, or we can say that if the object is reaches to ground, then a contact force, or we can say that a normal reaction force is acting upward and a downward mg is acting on that object. So we say that the weight here, we can say that the weight here, or we can say that the normal reaction is equal to mg. Here the normal reaction is equal to mg. Normal reaction equal to mg. So it balances and becomes rest. I think you are able to follow me. Thank you. Thank you very much.